We're going to get started. Thanks for everybody coming out for our, I believe, our second lecture in the lecture series this semester. It's an exciting evening to hear from Michael Guthrie about the work that he does with Inform Studio in his professional practice. I think for most of you it'll be interesting because they are currently, as you'll see, building a building on campus that you'll be familiar with. Michael Guthrie is one of the founding design principals at Inform Studio with offices in Detroit and Chicago. He received his Bachelor of Science in Architecture from Lawrence Technological University and his Master's of Architecture from the University of Michigan, where he was honored with an Alumni Society Award. Michael's accomplishments range from professional to academic. His commitment to the firm's progressive work is illustrated by a broad range of projects, including museums, libraries, an airport, hospitality, and a pedestrian bridge, with an innovative approach to sustainable design, and also to digital fabrication, some of the things that he'll be talking about tonight. Michael has been an adjunct professor and lectured at numerous universities, including the University of Michigan, University of Illinois, and the University of Pennsylvania. Michael has achieved significant professional awards and distinctions that include 28 AIA Design Awards and several projects achieving LEED certification. Additionally, Michael received a 2003 AIA Young Architects Award and was honored with the 2004 AIA Michigan Young Architects Award. His work has been published in Architecture, Architectural Record, ArchiWorld, See a Concept, Albania Magazine, and various other publications, and shown in numerous exhibitions, including New York, Guangzhou, and Cairo. So quite a resume. And with that, I want to welcome you to speak to us tonight and to all the people watching online as well. So thank you. You're my guy.
Does that sound all right?
Oh, yeah.
Good? All right. Thank you, Jim. Appreciate it very much. And it's great to be here. Really, it is. It was a little bit of a surprise, honestly. I talked with Carl about this a little while back and forgot about it, to be honest. But it was fantastic, the kind of timing of when to find this out, with a lot of things that we were even doing alignment-wise in our own office. So what you're going to see is something that's going to be purely authentic, a little bit raw, which is probably going to want that more than seeing something polished and sort of really thought out. So I think it's so raw that to start with, this was an email that we got yesterday in our office. You can actually see, I think up at the top there, January 17th. Forwarded it even this morning when I got a chance to look at it. The reason why we're looking at this being relevant, this is for a conference for CNU, essentially accepting proposals for innovation. If you're not familiar with CNU, it is the Congress for New Urbanism. They're kind of a national or global organization committed really to urban space, started with new urbanist principles, but thought it was fascinating that they have a conference in Savannah this year in May. They really were looking for open proposals for innovation. And what did they use for imagery? It's actually known as the Mural Building, if you're familiar with it. It is in Milwaukee Junction, in the kind of northern part of Detroit, near the New Center area, on East Grand Boulevard, essentially a quarter mile east of Woodward. So what I found that was fascinating about this, like getting it yesterday, is you have this kind of global conversation that's utilizing imagery and thoughts that are coming out of the metropolitan Detroit region, or Detroit, right? And so what we thought was really relevant with this is a place that's a hotbed for making and innovation. And what we want to really communicate to you, I think, in many ways, is start thinking this way. And I want to come back to this later in the lecture, really kind of summarize. So it'll come full circle. But as you go through this, really start to think about what is the future and the process of how we make things. And so when we think about design, when we think about architecture, when we think about construction, when we think about fabrication, assembly, all of these types of things, you have kind of conventions of how these work, but it is changing, and it's changing dramatically. And what we find is that people like you have way more opportunity to make an impact on that than, say, people like me. I'm actually that age now, so unfortunate, but it's true. I'll probably refer to a lot of things in this that I'll say, I didn't actually do this. I don't understand how this works, but here's the interface that helped me understand it. So to start with, I did promise that we would talk about the housing project. And so real quickly, just to set the context for this, generally speaking, when you're dealing with design and architecture in any kind of way, there's kind of three-part triangle to things. We call it cost, time, and complexity of design or quality of design. And usually those things have a reciprocal relationship, right? So if, I like to do this, so participate with me if you can. If the quality of design goes up, what probably happens to cost?
Goes up.
Goes up, right? And if the time needs to be compressed, what usually goes to the cost? Goes up, right? So usually these things have reciprocal relate. Well, the ambition for this was we want to be in it in a year and a half. We need it to be really low budget, and we have a really ambitious design for this. So not exactly working with this, but hey, we love Lawrence, and that was a great way to operate, and it was an incredible design challenge to kind of work to. So what you're going to see is this is the process that got us where we essentially are, and then where it kind of sits in construction and why right now. So to start, really looking at two components of the campus that were important to understand. One was everybody's familiar with the academic sort of part of the campus here. We called this North Campus or ancillary structures. And with each of those, what you find in a figure ground relationship is there's a really nice space that's sort of created within this. There's the potential for it here. But there's this sort of area in between that we were really interested in, and that was the idea of, could you create a district for housing, right? So it's a housing district, not necessarily just two buildings that are there. So we looked at the idea early on that there could be a collection of buildings that would then connect effectively the academic campus to the future development of ancillary space to the north. So the thought was thinking that, hey, if we look at this kind of linear relationship, so that there's a strong connectivity essentially from that ancillary part of the campus to the academic part of the campus, it could happen through this idea of a housing district, and then also create a space for a housing district so that by adding the third building and creating a sort of space there's something shared as a kind of public campus accessible space within it. So we started looking at this, kind of locating the building in this area. The idea was, again, that as we essentially project and go vertical, it creates a potential for essentially a campus space within it. But we also looked at it's within the parking lot. So within the parking lot to elevate it, to give it a little bit of a podium so that if I'm in a residential unit, I don't want to be looking directly out of parking, right? So give it a little bit of elevation so that it has a sense of privacy to it. And then we looked at the split. You don't want to feel as though, hey, it's broken, that you're not able to sort of see or make the connection between the north part of the campus and between the academic part of the campus. So this idea of a pass-through. The other condition that was really important within this is there's got to be a public component of this. In other words, if there's people passing by this or this is kind of gathering space, how do we treat the first floor so that it's not housing? It really feels more like anybody can use this type of space. It's probably not a secret. Football team is coming, marching band is coming, all these kinds of things. Maybe there's not as much access to the fitness facility. What are other programs that we could potentially put into this that could create a dynamic relationship that's kind of a used by all scenario? And so that kind of gave us this sort of sense of we take the whole ground floor and we actually accommodate this as public type of space that can be used for everyone. And then really, the housing component of it comes within modules up above. And I'll talk a little bit about the modules later that became very important from a cost-conscious side of things and really maximizing the efficiency of the housing project. From there, what was really critical is, hey, if we're going to have these zones for circulation and moving through to make it campus-like, that it's not vehicular-dominated, so really looking at pathways within green space and creating kind of public settings so that people could both gather and move through, and then allow the automobile to really be more of an urban relationship at the edge so it feels like on-street parking type of conditions and gives it a little bit more of an urban feel to it overall. We looked early, again, this idea of other programming that would be on the lower floor, so living room type space, cafe type space, fitness center type space. And then really within that, how could we also look at other community spaces within this, that this wasn't just a dormitory, but it's a pretty sizable housing complex? Where are the places that community exist? And so where we started with the idea of the sort of larger public space, we could take bays in those modules and kind of look at single, double high, or mezzanine type spaces to create those within that. So what we looked at then is, what's a series of programming that we could analyze and give a lot of differentiation to that? So you may have reading rooms, you may have game rooms, you may start to look at game rooms in such a way that one's more active, right? Like foosball, ping pong, things like that. One's more passive, cards, things of that nature. That there's a place that could even be sort of cinema for showings, for things that are going on, and a kind of dynamic relationship both within the building and externally to the building, and that those would be vertically integrated so that you can have neighborhoods or groups of spaces that happen in between these zones. And it was always the notion that there's never more than 24 beds collected together, right? You want to know your neighbors, the people who you are. So if you look at this, this is really almost city within a city, but then you have your neighborhoods and districts that become particular to what's there and the ability to traverse all through the building. So you may not necessarily just be in this part. If my room is here, I may actually come over to the other bar to access the music room community space. So we also look at that from a horizontal plane. Again, same idea, right? We have the whole public lower floor, but then this is broken up into districts. So there's kind of a grouping and a grouping and a grouping in terms of where the housing may fit into it. And a real critical component early on with this is, if we're looking to kind of maximize the efficiency of this, what is the module? So this was a given in a certain sense. It was, hey, here's what's worked in terms of housing. Here's the maximum amount of size that we want to give. And so what we said is, okay, we're going to play with the Lego that you gave us, and then we're going to figure out how we can start to look at the assembly of this. But let's break down the Lego into exactly what are the proportions and the criteria that's there. So essentially it's a 25'4" wide, 16 feet deep, and 10.5 feet high. And each module contains 2 units. So you would have 1 and 2 within this. And so effectively, when we start to look at these units, we get them in such a way that we're looking at them completely three-dimensionally. How does everything sort of fit within that unit? And that ends up being the core and the base. So we go back and forth, and I think this comes into then, what does the future of design start to look like? And we had the opportunity to work a little bit with a studio that was doing computational design to have a conversation about how do we use this as a tool in thinking about this. So what we looked at is there has to be a lot of different iterations that we would want to look at, the relationship between, say, these units and then these community spaces, and how do those arrangements work, right? So what's the right type of proportioning, where they are, so that we have dialogue between, say, second floor, third floor, fourth floor, and the right approximation. And so the sense was that there was essentially, hopefully I can get this to run. Went really dark, there we go. So right, there's a series of iterations that there are rules. So we never move outside of this core or this core for a stair, but everything else is sort of open for interpretation. And then working through that, you kind of assess, hey, here's the best places for these community spaces to stay. And then from there, within the modules, we have the 25'4" module. In order to be cost conscious, there's 2 types of windows. So you have a more square window and then a split. So there's, it's essentially set up so that what would be the right type of proportion to look at the square windows to 2. So you have a single and then a double. Within that, you look at a 25'4" ratio. And if you look at all the vertical lines, that was essentially approximated to look at right sizing metal panels. So there's only 3 different types of sizes of metal panels, right? So we build in this rigorous system. Then we can look at the manipulations within this, right? So that you don't necessarily feel the reading of this hard grid within it, but everything is within this very modularized type of surface, and then we can apply that across larger areas, and then you can see the kind of relationship and exploration we can do to give a diversification effectively to the facade. Applying it from there, essentially what we look at is, how do we look at the culmination or the aggregation of, say, all 4 facades? And one of the things that's really important is that the modulation of those windows then take place outside or around what these community spaces would be. So right, this neighborhood can be modulated and sort of moved apart in its direction, and each facade could be controlled in its own environment, subject to one another. The other thing we can do is start to apply parameters to these. So if we need 60% window type 1, we can start to move the needle there. Or if a contractor says, you know what, it's a lot cheaper if you go more of these, we can start to manipulate, hey, does it go up in the percentage of those or down in the percentage of those as we start to look overall. And the other thing we can look at is the amount of glazing you have on each facade within it and the percentage for daylighting. So a lot of modulation in terms of really giving you a number of repetitive iterations that then you take more the position of analyzing things than specifically designing one iteration after another, right? And so what it allows the computer to do as a tool is to give you multiple things to evaluate as opposed to specifically your priority or idea ahead of time. And more importantly, the strength of it is that we can put certain performance parameters into it that then we can measure and look at how effective it can actually work and perform. We'll talk a little bit more about that, both in terms of cost and performance as it relates to some other projects. Just quickly through the plan to give you a little bit of the lay of the land, this is north in this direction. Academic campus is in this direction. Sort of main entrance to this ground floor, which is fitness center and kind of public space. This is, in a sense, kind of residential space where it's kitchen, sort of living type spaces. And then an entry off of the courtyard space that's here that also goes into the dormitory. And again, this idea that this is all at grade, but there would be a small topographical change here where when you get into the housing, it's up. The other important thing in terms of getting a sense of as we move up is looking at the community spaces as they sort of sit within this. And so there's a lot of diversity in terms of the types of spaces they are. Music, individual practice room spaces, collective type spaces, different game rooms that are within these, and then looking at reading and social spaces. Always the idea that effectively as you move up, you have an open to below so that there's opportunities for second floor to connect to third floor to fourth, and then this really becomes kind of a critical piece where it's a larger, spans over to the mezzanine type of space that gives the terrace seating the ability to have films, lectures, any type of social type things, and just hang out in sort of seating area within that space as well. Really looking at giving a bit of grandeur to the idea of that entry so that it feels very public. The idea is that it would be all glass, really opened up into that courtyard or green space between all three housing areas. And then really denoting this idea of entry with these kind of yellow boxes within this. The other thing that you might see within this is we've treated the exterior envelope essentially with a little bit more cost-effective type of material, but it has this idea of enclosure. As it comes into the interior, it's more private, it's intimate, it's tactile. So the material quality is raised a little bit and gives you a sense of intimacy as you're within the interior. The cantilever, and we'll talk a little bit about this, we were looking at structural systems and what's the most efficient way to do it. So you get the good and the bad, right? We show you kind of the struggles and the things that we went through as we evaluated this project. When we first looked at this, we wanted to look at glulam timbers and CLT. Essentially, it would be all wood framed all the way through. We'd have the exposure of wood that was within it. Interesting aspect of that is that it would end up being columns and beams, and then allow the planks to essentially run in this direction, which means we're free as we go from space to space. We can kind of move and we're not locked into something. One of the things that's very interesting about this is we tried to very competitively work structural systems in, and that the timber was becoming competitive. But there's so many outside parameters that come in and affect this. And what was fascinating about this is as we were getting closer to closer and it looked like, all right, we might be able to deal with the premium that's here, it's actually the insurances on delivering and erecting the CLTs that ended up making it not cost effective at all. So sometimes beyond the parameters of what you would even think, just because there's the lack of familiarity that's there. So I think it's one of those types of things that we want people to understand the impact of how you have to make decisions on things and where they are is sometimes outside of you, if you call a vendor or anybody else, the cost implications may not be as clear as you might think. Again, the idea that it spans essentially north-south, or I should say east-west within each one of these walls. But then where did we have to go? So the most cost-effective solution that we essentially ran into was the idea of block bearing walls with concrete plank. And you see this a lot in different housing types. But this had to be a hybrid type of situation because that ground floor couldn't bear essentially having all of the masonry walls that are in a regular pattern. So as we kind of look at the erection process within this, you can't see it very well, but essentially from this point forward is all steel, and then you can see the steel move up within this area. And the reason for that is because of the cantilever that you see on the end. So essentially the structural steel moves up, and it was actually kind of intelligent idea by our structural engineer to look at essentially plate girders that were on the roof, so that we didn't have so much spanning and sort of girder trusses that were within the fabric of the actual spaces that were being utilized. So it didn't inhibit door openings and things like that as much as we would generally see. And then additionally, you can see, okay, here's the modules that are sort of broken up, and the idea is that 2 sets of rooms within each module. Again, as it's starting to be clad, the girder trusses just disappear in behind it, but it gives us the ability to really have all of this being open, particularly so that you have the ability to see into open public space, and it would be very accessible in such a way that you can have program space on the exterior. So you have that real strong relationship between interior space that's used and exterior space that's used. And then also that kind of transition as you go more towards the courtyard and giving you a very different read and a very different feel within this. And the idea was that it's not just a conduit to get from one part of the campus to the another part of the campus, but it's also a place to kind of sit and be peaceful and more serene. And it was interesting because we were having a conversation earlier about what's the right kind of proportion or scale of this. And as it's been erected, we think that it's come together very well in terms of a very intimate type of courtyard, but then also having a very interesting relationship between those public spaces that are then looking back onto that, right? It adds a kind of dynamic to it. And then looking at even the relationship of, say, the very public space that's here, the music room that's within this zone, but also treating things service-wise like laundry so that you get the connection of, hey, this is vertically where all of these service things are kind of collected. So the laundry is, in a sense, predominant, and we're also providing natural light then into the laundry rooms that are there. This gives you a little bit of that sense of what the interior of one of these spaces might be, where there's rooms within this area, spills out to a common space, and then is open effectively to the floor below. So again, it's very strong in its conversational relationship from one level to another level, so that the idea is that you're building communities, so these groupings of like 24 students, but then you also have the ability to cross-pollinate both on the horizontal plane and in the vertical plane. This gives you a little bit of the sense of the intentionality of looking at a very active game type space. So it's more along the urban or southern edge of the campus. So as cars are coming by or people are looking back, you can see when there's a lot of activity happening within that zone. At the same time, the little bit of elevation deviation that's there, and that affects essentially the entry where you would come in at grade, small stair that's effectively there, and you sort of stare up, and then you have the ability to have that elevation change. You think of it a lot like the way row houses work, right? So you step up and you can see the activity that's all there, but you have that sort of private zone that you actually live and reside within. And so you sort of read the base of where that exists, the idea that there's that very public active game space within this zone, a more passive game space within this zone that connects again third and fourth floor, the study type carrels that would be on the fourth floor, and then again a more private, quiet reading space that connects both the second and the third floor. So again, very diverse types of spaces that exist within it. And then collectively, it gives a very strong reading to the idea of 10 Mile, of Southfield, right, or the service drive, so that people get a real feel of the activity of what's happening within the residence, while still leaving the individual rooms as very private things, right? Because you're not seeing it at the scale of the individual housing rooms. You start to see from a distance the more larger scalar components of the community rooms. And then really, the largest kind of community rooms speaking to that kind of public space that's created on the west side, and then the dynamic of, you can't tell now obviously because it's Viz Queen and not glass, but how it would connect to that public space. So as you're walking along, you're seeing the activity that's there, coffee bar, fitness center, kind of all of the activity that's really within that zone. And then again, coming back to the idea of that mezzanine space and what it means in terms of a volume that's effectively accessible. And at the same time, it's still driven by this idea of the rigor of exactly what the structural system is, being the masonry walls and the concrete plank. And so that gives kind of a summary, I think, of the housing. But what we wanted to move to a little bit as well is just kind of share this idea of computational design, and particularly as it relates to digital fabrication. So if you're familiar with this at all, this is the Illy Coffee Bar in the McNamara terminal. And this was kind of our first foray into really conceiving the idea of digital fabrication. And I show this just to give you kind of our starting point for this, right? And so effectively, this whole thing was sort of built within a factory, disassembled, and then brought back on site and reassembled. So what are the advantages of something like this? Many, but in particular, you're building in a very controlled environment, right? I'm not bringing raw material out to a site and working within the elements. I have the ability of manufacturing tools that are there, clean rooms, comfort of people who are working there, eyes on everybody who's doing things in a controlled environment, as well as cost control within those. I'm not subject to the elements and all of the things that are there, and an incredible level of accuracy within that. You're also able to work in a way that's sort of speed, and so some of the obstacles that come in then is kind of delivery to this. How are you dealing with the assembly phase of it? So we really look at it as there's a certain level of fabrication, and then the assembly goes in. What was exciting for us is to be able to sort of scale this up, and this was scaling this up a lot. This is the Providence Pedestrian Bridge in Providence, Rhode Island. This was actually a competition that we won in 2010, and so sometimes, you know, where time really compresses you, this gave us a lot of time to sort of add things in as we go in terms of technology, thought process, how would we build. So initially, when we looked at this scheme, I'm not going to talk so much about the design of this, but just to give you a sense of it, is there was a lot of directionality with this. So there's the east side of the river here, west side of the river here. Brown University is over here. Fox Hill neighborhood is here. They have the Riverwalk within this area they're calling the Knowledge District that they want to expand to, a kind of proposed boulevard known as Dorrance, and then the Riverwalk here. So you get a sort of sense of all of the directionality that this thing wants to move, right? And they also had this kind of heritage of shipbuilding and making and jewelry. And so there was a lot of kind of sinuous relationships that were built into the overall form of this, and then really working with the idea of wood. So what this is illustrating effectively is the overall model. This is done in Rhino. And you get a sort of sense of the sinuous nature of things, some of the complexities of double curved geometries and things of that idea, so that it has a very consistent movement as you go from one place to another, and it allows you to deviate directionality and yet still maintain a holistic integrity, right? It never fractures, it never creases or folds. It's always a very sinuous movement and bend. And so the idea behind looking at this was, how do we even construct something like this over the river? What are going to be the challenges in doing this? And so what we came up with is the idea of taking a process of digital fabrication and working with essentially a subcontractor. The person who got the job is out of Brooklyn in the Navy Yards. And what we were able to do is work with them in such a way that we would give them the Rhino model of what you're seeing in the wood effectively here as the deliverable. We wouldn't draw all of the drawings that were there for constructability. So in thinking through that, there's really two models that were put together for this. And I really want to make the comparison between what worked well and what is difficult and what didn't, because it was surprising, shocking even in a certain level. So essentially the primary structure, and you saw sort of two zones. There's kind of the clear span, and then the other part that looks like it has the hull or the deck that comes closer to the water. So within the area where the hull comes closer to the water, there's two systems. One is a Revit model, which is essentially all of the primary steel that's within it. And the other is the Rhino model, which is essentially the skin or the wrapper that comes around it. And so as we look at this, you can see the kind of deviation between the amount of structure that's happening within the Revit model. That was all done in terms of conventional construction documents, drawings that were sent out, steel detailer sends back drawings, get approval. I can't tell you how painful that process was. The amount of inaccuracies, this doesn't match, that doesn't match. I mean, it was a lot of Excedrin, predominantly Corey. I feel bad for the man. You know, just, I mean, an incredibly painful process to go through. We were almost nervous about, wow, what is this going to mean for the skin, right? And, you know, now we're kind of advancing into new territory. And so you see the different layering that goes into this, particularly as it goes back for the busker terrace and other components of it. So what was interesting about it is that they're still making them in sections. This ends up being the more conventional construction side of things, where they're taking them in bays and essentially supporting them from pier to pier. And you see the kind of movement that's going there. I think interestingly here is that the south side, what you'll notice is that there's a much more tapered thin edge to it, the north side being quite different than that, which is a thicker edge, and then obviously all of the manipulations in between. This is definitely indicative of Brian's disposition through the entire project, even so much, I don't know why he's wearing a hat that says Kevin, but you know, young guy, super bright. This is a Department of Transportation project. It's for Rhode Island Department of Transportation. And so what we're trying to do is accommodate this very unique kind of process in something where they generally just build highways. So this was a very different process to go through. The conventional sort of method of things, although challenging, was the way that they do things. What's been fascinating, though, is to see then how that translates into the wood skin around it. And so what was fascinating is this is the kind of documentation that we're effectively doing for the skin of the bridge, right? It's very referential. It's not telling you everything that you need to have within it. And it's broken up effectively into 5-foot sections, right? Every single one of these is a 5-foot section. So as we start to think about this, essentially each of these slide onto the bridge. You can see kind of on the thin area on the south side, and then this would be the thicker area on the north side. And then a lot of transition happens as you get closer to the hull. And so the idea was, okay, let's prototype or mock up a little bit of what this would be. So it was essentially developed. It's a series of slats in this kind of 5-foot section. This is shout out to the Make Lab here. So Zuby actually came in and had these routed out of foam that were here so that he could make effectively a prototype and bring it back to our office. And then you can see kind of the early prototypes of what they're doing in the manufacturing process of it. So effectively, what we're really concerned about is sort of this area, that line, that kind of skin, and they take care of everything back from there. So what it allows us to do is be very free with, hey, however you want to work through the fabrication detailing of this, what you would have is sort of secondary or tertiary structure attached back to the primary structure, but we can effectively be within 1/16 of an inch over 330 feet tolerance for where that wood is and its relationship from one piece to another. And then that also parallels the idea of furnishings and things like that. You can see it went back to more conventional detailing, every little piece, every measurement, this, you know, here's all the assembly, those types of things. And so you have all three of these things paralleling themselves in terms of fabrication, right? That primary steel is being installed still now. The wood is going through its initial periods of fabrication, and the steel is essentially being fabricated all at the same time. But because we can rely on and count on the tolerance measures. They can all be built simultaneously and then installed because they'll be so tightly aligned with one another in the end. So it's really been a fascinating process. I think as we started to look at the wood skin, it was kind of like we gave it to them and they were like, it's good. And comparatively to dealing with the steel and the countless number of change orders and things, in terms of working through that whole process from a conventional point of view. This is a Ferrari dealership. Actually, you can kind of see this. It's right up Orchard Lake Road in West Bloomfield. We won't really go into the design of this so much as what does it mean in terms of taking this idea of digital fabrication again. And so, again, working with conventional construction, kind of, typical construction drawings. Here's metal studs. They're building the sort of shape of the thing overall. It comes out, looks more or less like what was it within the drawings. Then the metal panel manufacturer comes out and they say, this doesn't exactly match up to the skin that you had, and there's a lot of deviations, and the alignments just aren't there. So from a technology point, and what we found is really fascinating, is that they were able to come back and essentially take point cloud measurements, right? So they put lasers in certain areas and they collect data, and it effectively makes this point cloud to be able to say, hey, from existing conditions, here's a three-dimensional model, and essentially exactly what it looks like in that condition. So then that 3D model comes back to our office, and then we're effectively able to take the skin model that we had and manipulate it to fit exactly to what the point cloud model was. And so in doing so, it was remarkable to see the development of this. It goes from studs, and then off of the new model that was then created, they're able to make up the differences essentially in what's girders. They're kind of girts that come out, and then the insulation fits in between, where then the panels essentially clip onto the girts. And so you can see the kind of tightness that's arranged here. What's really fascinating is as you start to look at the compound bends and where they're able to effectively deal with these, and the kind of, I won't say that this had no budget, but when you look at some of the compound curves and things that were accomplished within this, probably wouldn't have been able to be achieved without digital fabrication. And in sort of many of the ways you can see, where these things kind of bend on the edges, but then how tight these tolerances are on these compound curves, and for them to be able to, even within it, you can see some of the stress within the panels, but they're all sort of perfectly shaped and formed, essentially straight from the digital files. So the drawings weren't necessarily created as anything more than referential in terms of the fabrication of those panels. And this is even as recent as maybe a couple of weeks ago or last week in the snow. The last project we wanted to show you isn't necessarily under construction, but I think this really gets at where this can go and what we're really excited about. This is for M1 Concourse in Pontiac. And so the interesting thing about this project, it's kind of a, well, I won't go into the programming so much, but this would be a public space for an area that they have kind of car condos, and there's a racetrack there. This would be really restaurant type of use and public space that people can gather at, meeting, ballroom type space within it. But they were very interested in this idea of speed and how to capture speed within the facade. And so we looked at this metal panel arrangement that would have a lot of movement to it and texture to it. But as it had these sort of dynamic relationships, this is actually a very simply constructed box. So how did we deal with the idea of panels that were both away from the primary structure and the limitations that were required of that, and then the individual metal panels themselves. So in looking at that, the idea was rather than having a sort of multiplicity of different types of panels, we would distill that down to, okay, we just have 5 panel sizes, flat, 2 deviations, and then the corners were particular nature. So the corners were kind of tricky because, right, you get this thing that doesn't look so great. And then how do we come back and we kind of resolve this and write something within the script so that when it's at the corners, it sort of resolves that solution. And so This is kind of the world that it lives in. I have no idea what any of this means personally. Like, it's Greek to me, right? And so this is kind of the scripting interface that computational designers in our office work with. They do an awesome job with it, and then they make things like that people like me can understand, which is fantastic. And so there's kind of a whole bunch of parameters, effectively from Grasshopper to Rhino, and then also from taking the Rhino model, moving it into Revit, and then working with Dynamo so that it can converse effectively with Revit for the documentation side of it. So you get all of these different types of interfaces. So this stuff that you guys are like learning now, please get really good at it, because this is the future of where things are going and what makes the kind of process of making so exciting. And so I just want to include this piece real quickly to give you a sense of how the parameters work for an interface that I can understand. So effectively, each one of these points has a particular location. You can kind of dial up and out. And the idea is that each one of these, if you look at the gray that's sort of set back within this, that's the primary structure. And then the sort of orange can be manipulated with a certain distance away from that primary structure. It can never be more than a certain amount of feet and inches. So the idea is we can work with the overall form, bring it back to what's within the acceptable restraints. We get it even to kind of the tight nuances and the details of where we need it to be. Then we go to the individual panels. And with the individual panels, we can have a certain percentage of each type, right? And so we can move that. We can manipulate that in such a way to give us the composition that we want. And then at the same time, we can dial up or dial down any one of the types of panels with cost control associated with all of these things. So depending on what percentage type of one panel that we have or another, that gives us the ability to then figure out, okay, if we do more within the corners, we can do less within other areas, and to really effectively deal with the cost control and kind of mediate this whole situation. This has been so effective. What we found is that in talking to some large construction firms, particularly in Chicago, they wanted to dial this in so that we could dynamically look at the cost of an entire building based on the parametrics that we put into it, which is an amazing thing to kind of think about, because how long do we do things where we design, we have no idea what the cost implications are, the contractor gets it, he comes back, and you end up with this painfully iterative process where you're doing this the whole time, rather than dynamically understanding that information as you go. That is where the future of this really is. And so kind of coming back to this piece that we started the lecture with, and what was really interesting about this is, and why we noticed it, is a project that we're working on. And this is known as Chroma. But I think what is so appropriate about this, the timing of this lecture, the timing of that email, is that this project is very much about the idea of a city of design. And if you don't know, Detroit was given the UNESCO designation of City of Design. It's the only one in the United States and only two within North America. And the thought behind that is that Detroit is known as kind of a pioneering landscape for where innovation of making occurs, right? Everything from fabrication of things to assembly line, that these technologies have always been here. It's been a part of the history, and we see ourselves very integrated and within that. And the other aspect of that is that it's very cross-disciplinary in the way that it's thinking, right? That we don't work in a vacuum anymore. We're not the architect genius that's over here doing this. You need all kinds of disciplines to collaborate together. And even outside of those, if you look at the creative disciplines, what's really fascinating about this is there's music lab, kitchen incubation, not-for-profit making type of spaces, jewelers, music, right? That you kind of open up the ability of where your influences may come from and the ability for how people think about making in a place of innovation. And that really becomes what this project would be, which is Chroma. And I think what we look at this as, particularly as people who are in the mainstream process of being in designing and making and building, inviting you to be a part of that dialogue that's a very beginning of the conversation of how do we make things, and that a design problem is the design of actually how we go about making things. And I think that's what's so exciting for the group of you who are within this room is to be a part of that conversation and understand that within this metropolitan Detroit area or within Detroit, you don't have to go to New York, you don't have to go to Los Angeles to be both within the experimental and influential, that this is the hotbed of where the entire globe is looking and will continue to look and to be a part of it. So just wanted to invite you and say thank you for having me today.
So we have time for some questions if you guys would like. Yes, and you have to talk in this for the people on camera, even though it doesn't really amplify your voice.
So, like, back to the building here, like the housing project, like a simple design element, like the buildings aren't parallel to each other. Is there reasoning behind it, or?
Sure. Yeah, and I think oftentimes we go through these iterations so that we can measure things. And the one thing that we didn't show is sort of previous iterations. Is it a courtyard concept? Is it, different types of looking? And it was very much intended, if you look at the scale of academic campus relative to moving north, right, it wants to open out as it comes to academic campus and then become more intimate as you come to the entrances to the north.
Okay.
Any other questions? All right, Alec. Gonna make me get my exercise, huh?
Got an arm?
I had another question about the building on campus here. When you went over the parametrics of the windows, how you could do a double window or one large window, you said that it gave you some options for anything that come up in like manufacturing or on-site construction. But you didn't really go into specifics on what happened to determine exactly how it is set up right now. So what did you run into in manufacturing or construction that determined how those windows are laid out right now as we look at the building?
Yeah, so not necessarily like in the construction process or the manufacturing process did that influence it. It was more early conversation. So kind of going back to that animated video, the parameters that sort of set it up, there's a certain size of metal panels, and what we were looking for is that rather than have this incredible rigor of consistency so that everything looks like this complete grid, is how do we accommodate for variation for certain aspects, but work within that variation so that it's very economical and cost effective, right? So if you recall, there's kind of 3 different sizes of metal panels that were there. Then the idea was within the window composition, they would obviously fit within those metal panel criteria, so they never cut in one into the other. They always fit cleanly within it. And then the sort of split allowed us so that depending on, in other words, the parametrics would only put the vertical windows where they could actually fit within those dimensions of those pieces. And then so that is just then working through, you see a number of iterations, what comfortably works as a composition, fits within the right amount of daylight and proportion, both to room and entire elevation. And then the overall proportion of, say, number of window type 1 to window type 2. And so you kind of move and manipulate all of those things from the performance criteria and then look to see from a visual side, yeah, compositionally this is making sense with the larger scale units of the common spaces, as well as, okay, you don't have a whole bunch of groupings of, say, square over here relative to the double windows that are there.
Okay, we've got another one here.
Hi there. My question was, with the technology that you guys are using for figuring out these complex systems for your structure, how is that, like, how freeing is that for you guys to really think about the overall package that you guys are delivering with every project that you guys are making?
I would say that's very much in process. So most of these have been painful because it's sort of first time around. I mentioned the idea, particularly when we were working towards the bridge. We didn't know, like, okay, from the fabrication side, how is this going to sort of push back on it? What you're seeing in these are things that are under construction or almost completed in construction, right? I didn't show you a lot of things that, like, this is done. So how that then affects the future of our processes, interestingly for us, I don't know, it's hard to, I can only say from a personal anecdote side of it, because we don't know how industry-wide things are working, but we've actually been going through sort of strategic planning initiatives on exactly what our processes are going to look like in the future. Where do we invest in R&D, training for people, all of those types of attributes to start to say, what we do recognize is that computational design is incredibly influential, and that digital fabrication will have the future to be more economical, more exploratory, and provide much more consistency and accuracy. So it just makes sense to commit to those kind of things. We don't know exactly how that's going to be leveraged, but you can see the early indicators that say we could do more in the model and a whole lot less in doing drawings and achieve a lot higher level of accuracy. I would say the more difficult, challenging proposition is finding the partners to make it work. In other words, because this isn't necessarily completely conventional mainstream, you're working with clients that, are you comfortable with putting a team of people together ahead of time rather than going through a conventional design, bid, build process? How are authorities or jurisdictions going to look at things in the permitting of drawings? How are they going to look at things in the inspections of things? So as more things are, say, assembled off-site before they get there, how are we looking at the assembly of things? So there's a lot of implications for where this is going. But we see much more optimism in the potentials of where it can go. And really, I mean, when it comes down to it, you can build better environments qualitatively and economically if we can find ways to free up and serve a lot of these other solutions. But we have to have the tools to be able to get the efficiencies out of those. And I think that is really the intent and the core of, say, what we were hoping to convey today.
So I have a quick question that adds on to that and ask you to expand a little bit on it. One of the things that I'm interested in is that traditionally when you administrate or construction administration in an architectural project, you have the specs and you have the drawings. And those two documents together are what the architects produce and are traditionally referred to as the instruments of service. And they're very defined in contracts, and they're defined through a history of legal rulings, et cetera. So what happens, at least in your experience and how you're seeing it formulate, because this is all happening, right? It hasn't been planned. How do you see the contracts evolving and who's responsible for what piece when there's no longer a drawing? It's a model that in some ways is shared.
Yeah, and so the interesting aspect of that is where we've come into this, it's very commensurate with the original way of thinking about things. In other words, typically we would do a set of drawings, it would go out to a detailer, he would do shop drawings, he would send it back, we would approve the shop drawings, stamp them and send them, and then they kind of build it. They hold the liability for their shop drawings. We hold the liability, for the original design drawings and kind of the detailings inherent within those. I think the Pedestrian Bridge is a really good example of that, because this is a group that really, they go by the rigidity of their process. And so that actually went through a process where we vetted out, and you had to be pre-approved to bid on the wood and the railing primarily. And so that was given to 3 people who they knew could actually use the technology, understand it, demonstrate the ability to do it. So it kind of took that governance side out of it. And then relative to the legal requirement from it, essentially we issue the model. The model is, although used, it is called referential. and then they build their own model, but essentially they can use our model as the basis, and then they send it back to us, and then we approve their model. So we have a model, they have a model, it matches identically, but it's their model. So,
So it behaves exactly like shop drawings at that point.
it's very, very similar. What the future of that looks like is hard to say, and we do have internal conversations about this, you know, when you can find the kind of aside time to do that what does this mean for liability? And so those are certainly all of the kind of things that they need to get worked out, and it's why this thing doesn't turn over overnight. Yeah.
Did the design process just generally shifted from hand to computerized sort of like process? Is that like how the industry is actually going toward, or there is like special cases where not every single design has to be digitalized and using a script or other process of like augmented computerized parametric design?
If I think I understand your question, I'm going to try to rephrase it. Some of the transition of, say, this process of both design and making, this is not a new idea, that there has to be a paradigm shift in how we do things. So a more simple way, you know, this is kind of more my generation. People were drawing by hand. I actually did that at one point. I think people still do that. But right then they made the shift into essentially computer-assisted drafting, right? And so, you know, suddenly you're doing everything there. Well, this is like an industry shift, right? And you see that start to change. And the next level was everybody went to, or, you know, people are going to BIM. And so, you know, now you have Revit is the more predominantly, say, used software within the industry. And so this is kind of taking that next step in transition to that. There's a lot more complexity to this because it's not just, oh, you know, how you draft or represent things. It's literally affecting how we make things. But it has, if you think about whether I drew it in CAD or whether I drew it by hand, it in no way changes how people were manufacturing or the process of making, right? Nothing to do with it. They read a drawing and they effectively went about their craft in the same traditional method they did, or it was a completely independent venture if I chose to go some other way. These are intrinsically tied together. Fabricator, assembly, designer, all of those people are kind of lock in step. So it has more of a cultural implication of how it affects the industry, but that's where we look at it and we go, this is so great to be referential of other things. What is automotive doing? Because they're doing things similar to this, right? So you can look at all kinds of disciplines outside of, say, the building industry and say, product design or other things, how is it affected in those areas and what can we learn from what they're doing? Because the reality is, from design of environment standpoint, we're behind every other discipline, so we have the ability to effectively learn from other people who are doing it ahead of us. You're getting your steps in.
Yeah.
Well, really fascinating. So, as you say, you were going through these painful processes. These are your initial ventures. Are you finding the time to actually sit back and, I think, recall it methodically and then actually bring that out as either a tool for learning for your office or for other people as well?
Yeah, that's a great question. And I think this goes into practice. How does practice work? I would love to say that's been the case. I think we are becoming more methodical about that now, in the sense that I know there's a number of people from our office who are even here, and some of the things that are here, they're seeing for the first time pieces, right? So there's groupings of people who are working on segments of projects, but it's very hard to give, like, okay, what's the full capture? And so I think what we want to be really committed to, and we're an office who is smaller too, so it's a little bit different, right? We were always like 10, 12, 14, and we're 40, I think, now. And that communication is totally different than it used to be. It more haptically just occurred. It was very organic. And so for us, it's even learning, it's not just, this entire wave of looking at the discipline. It's understanding us as an office culture, how we communicate. And that needs to be a lot more intentional, formalized, worked through, because the only way this is going to be successful is we want everybody to grow, advance the exposure to it, the capacity to be able to do it, the ability to be able to do it, all of those types of things. So I would say that that's something that's kind of an initiative within our office, is increasing the communication and then the training and exposure. And obviously, I mean, the great thing is, how do you partner better with universities? Because that's where the learning of it really is on the forefront. So as people are coming in, how do we listen and hey, here's where we are, what do you know, and kind of create that communication beyond a one-to-one also, kind of a greater collective of people.
Well, Michael, thank you so much. It's been great listening to you, and it's great to have an alumni also speak to us and show us such great work. So thanks a lot. If you have more questions, I'm sure he'll take them up here.
Thank you very much. Do I hold?